First step is always draw your free body diagram.
Yeah.
Let's see. Force. So you have a weight going down.
Mm-hmm.
Is it on a pulley?
It is on a pulley.
Okay, good. Like that. And that attaches to this, the cart.
Yep.
No friction, so that's good.
Mm-hmm.
And that is attached to another pulley that has two forces going out like that, because there's two cords.
Right. So wait, is the other box the cart?
Yeah, this one's the cart.
Okay.
I
pulley's actually above it, yeah.
super simplified it. I simplified it.
Okay.
Just to make it easier to look at.
Yeah.
Pleasing. So here, on this one you have gravity,
Yes.
you have the normal force,
Yes.
and you have this tension right there.
Yes.
You can cut that. That means on this box we have tension and gravity. And it says it's moving 9 meters per hour that way. Is it fixed?
9 meters per hour.
9 meters per oh,
Isn't it miles?
miles per hour. Miles per hour. Yeah.
1.5 miles per hour. Ooh. Oh, gross.
We'd have to convert from English units to metric. Oh well. We'll do that later. Wait, the map.
The length is 100 feet. That means we have to convert that to meters.
We don't care how fast it's moving, we just care how fast it's accelerating. Tricky, tricky. Okay. So now we have our free body diagram. We do our sum of the forces in the x and the y for both free body diagrams.
Yes.
So here we have for sum of the forces in the x. You have that force in the x, that's that tension. So let's call that tension 2. And let's call this one tension 1.
Mm-hmm.
Plus t plus t. And since it's accelerating to the right, it's going to be equal to mass times acceleration. Mass
Awesome.
1. We'll say that 1, 2. Awesome. Sum of the forces in the y. You have that force, which is just mass times gravity.
They cancel each other out, like the mass and the normal force.
Yeah. So that's just negative mass times gravity plus normal is equal to 0. That tells you that your normal force is equal to mass times gravity.
Yep.
And that would come in handy if we had friction, because friction is equal to normal times mu. So with that we could find friction, but in this case we don't need it. So root for us. This one, you have to do the same thing. Sum of the forces in the x, since there are no forces, it's just 0. Cool. And sum of the forces in the y, that's equal to mass
Gravity
2 times
minus-
gravity.
Is gravity minus tension or tension minus gravity?
It's
But it's
tension minus
accelerating.
gravity. It's tension minus gravity because it's accelerating up.
So it's tension minus gravity. Wait, it's accelerating up.
Because this block goes this way, that
Uh-huh.
means that this one has to go up.
Has to go up. So
If
the
this one were
acceleration is
going
gonna be
that way,
positive.
then I would go that way.
Cool. Got it.
Plus your tension 2. Keep in mind that that tension and that tension are exactly the same.
Yeah.
And that is equal to mass 2 times gravity.
Mm-hmm.
Not gravity, acceleration. That acceleration and that acceleration are also the same.
Yeah.
Very, exactly the same. And we are looking for this tension, right?
Indeed. Wait, which tension?
Tension
That
on
one.
that one.
The tension that's pulling the car, right?
Cool. So we'll just call that tension times 2 because there's 2 tensions, so just compete. Awesome. Well, it looks like we don't need that anymore because we don't have friction, so we're just gonna erase it.
Yeah.
'Cause that doesn't help us with anything else because we don't have an n. So that. All right.
Mm-hmm.
How many unknowns do we have? We have
We have tension. We have acceleration.
tension 2 and acceleration.
I think that's about it. I mean,
We need one more equation. Let's see. What do we know?
we know the mass. Yeah. We know the mass of the block.
Oh wait. back and forth on the rail. So yeah, this that picture really doesn't help us with the problem. Like, it doesn't look like a cable car.
Yeah.
All right.
It tripped me out too.
I think this one has a lot of red herrings, like stuff that you don't need.
Red herring. Kind of like Morning Glories.
I guess so, maybe. No, I've never heard of that as a like a way to misdirect. Is that what it means? That's cool. I don't know. Dang it, why? I'm gonna read this carefully. I don't know. Thank you. Find something. Oh. Ha. We're not. It's not accelerating.
It's not?
No. It wants it to stay still, basically. So.
So I have an equilibrium.
Yeah. That's nice. So that's 0. That's 0. That means we can solve for tension. Yay.
So cool.
Yeah. So let's see. T is equal to. That's T2 over 2. Solving this equation, you find tension. The tension that we're looking for is equal to T2 over 2.
T2 over 2.
Because you divide that T2 by 2 and add that across. So then you solve for T2. Mass 2 times gravity. Then put that T2 in there. And solve for T1.
T2 into that T2 right there. And
Because you solve this for T2.
uh-huh.
That's T2 right there.
Right.
Then you take that and plug it in right here,
Right.
and that'll be your T1, the one that you're looking for.
T1 equals to T2
Mm-hmm. Over 2.
over 2.
Yeah.
Okay.
There's an over 2 right.
Let me see that. I'll set that up. So T1 and
Did
then
it graph?
T2 times 2.
So I don't really know what we're supposed to graph.
Oh, okay.
So he wants us to like kind of get creative with it. So we could do like
Let's get creative.
position versus time, or like position versus
time. Let's do position versus position.
yeah.
That would be
You
fun.
mentioned one of those.
Let's do like that's a lot of data. Holy cow, they got really fast.
And like once it comes like past 4 seconds, it's like you have like to E -5, E negative.
Oh, that's weird. Something's going on.
Could be the total drag.
Maybe. Negative that times that times that. Okay. Escape. Escape. So it should like level off to 0. Oh, yeah, it did level off to 0, but
Really that simple.
how heavy is it? That heavy?
How heavy is it?
Yeah, that
It can be as heavy as we want. could be a golf ball, it could be baseball, it could be a rocket.
2. Oh, you want this to be. Ah. That makes me feel better. Made me feel much better.
How'd you figure that out to change the time?
Intuition.
Intuition.
Where do you insert? Table.
You're looking for charts.
Graph.
Go to the chart.
Line. I selected it. This is where it should. Hello.
Maybe you should use.
Oh, line. Ha, this thing. That's why. Like they didn't just create a whole nother thing for it. Then it should pop up. What's weird is
The acceleration split.
well, this is just that
positions?
that X. It shouldn't be on there. It should be. Right click.
You do
Dual click.
double finger. I also have my mouse right there too. That'd probably help.
The range. Name. Okay, I don't want that. Delete. Y values. Maybe that. We know that was the Y. Ah, I broke it. I broke your math.
It's always undo.
Yeah, can I see your mouse?
Yes, right there.
That'd be nicer. Although it does feel that the touchpad is really nice because it's. Change select data. I will take this one. Escape. Select data. Oh
It
wait.
should be plus. Close now.
Delete.
Plus T.
I want delete the X, the Y value I want. Oh man. The Y value I want this one. So weird. I don't like how that's highlighted. It's weird. You go to select data. Weird, it's like different. Oh. Oh, you don't need it. Remove.
What are you trying to do?
I'm trying to plot it, your y versus x,
Oh,
kind of like that.
okay, so here's my,
And home.
that's pretty cool.
So that's y versus x.
So this is my X right here, and the red line is my Y.
Yeah, so your x is that, and then your y is that right there. That's cool.
So it drops off pretty quickly.
Because I don't think that angle that you guys set off at.
We didn't have
Oh,
any-
because let's go like this.
What did that change?
Just go 100 in the x, 100 in y, then boom. And if you go like 1 in the x, oh, so the angle comes from here. This is where the angle is.
Mm-hmm.
And so what it's saying is that I want to do it with respect to time. That'd be better. Y with respect. So this is where you change, pick your x-axis.
Mm-hmm.
I want that to be time, not x. Okay. That's with respect to time.
What if we did like time versus velocity?
Yeah, you can do that. And then you just play with it. You just put your numbers in here, and away you go. That should just give us that. Enter. And then it starts to just slow. Yeah.
And if I want to do that to like, let's say I want to change my Y to acceleration Y.
Oh, then you just go in here, select data. Whoa, nice job.
I don't know where to go from here though.
Okay, cool. You just delete that.
This one?
Yeah, that whole thing. And then select the one that you want.
Okay.
Cool. So this is this one.
Yeah.
Horizontal force, which is on the thing, mass of that, tension of the string is 12. Tension string 1 is that. What is the F? Cool. This is really good. So,